Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at piecewise functions. Now, a piecewise function is a function that's defined by different rules for different intervals in its domain. The first example that we have, f of x is equal to negative 2x minus 4 if x is less than 2, but it's equal to 3x plus 1 if x is greater than or equal to 2. So each side is a linear function. It's important to know which intervals are including the endpoints and which ones aren't. So here, the second branch, x is greater than or equal to 2, means that that's going to start with a point, not an open circle, indicating it's not part of it. I'm going to start with the first branch, negative 2x minus 4, when x is less than 2. And graphing this part is actually a little tricky. But if you follow this approach, I think you'll have some great success with this. I'm going to start with a table of values. So x, and I'm going to have negative 2x minus 4. And I'm going to pick values of x that are less than 2, including the value 2. And I'll show you why I do that in a moment. So 2, 1, 0, negative 1. That should be enough to give you an idea of what happens here. When I substitute in 2, negative 2 times 2 minus 4, that's negative 4 minus 4, or negative 8. So that means that at 2, negative 8, I'm going to put an open circle. When I substitute 1, negative 2 times 1 minus 4, that's negative 2 minus 4, or negative 6. So 1, negative 6, I'm going to put a point there. At 0, when x is 0, negative 2 times 0 minus 4, that's just 0 minus 4, or negative 4. And I can see the pattern. I'm just going to do one more. Negative 2 times negative 1, that's positive 2, minus 4, that equals negative 2, negative 1, negative 2. I've got a point there. So I can see that as I look at this from left to right, the slope, negative 2, it's going down to right 1, down to right 1. If I had started at that open circle, I could have used a reverse slope. And so instead of down to right 1, I could go left 1, up 2, left 1, up 2, just reversing that slope pattern. Anyway, the left side of the graph looks like that. Now, if the other branch happens to coincide with that open circle, I'll fill that in. But if it starts somewhere else, I won't. We've got f of x equals 3x plus 1 if x is greater than or equal to 2. So I'm going to use the same approach here. I'm going to start with 2, 3. We'll see if we need that, 4. And I've got 3x plus 1. 3 times 2 plus 1 is 7. So I've got a point at 2, 7. 2, 7. By the way, that tells me that this function is not continuous at that point, because I would have to lift my pencil to get from that lower segment up to this next segment. From there, I could use slope to graph it, but I can plug in as well. 3 times 3 plus 1 is 10. So I've got a point at 310. 3 times 4 plus 1, that's 12 plus 1, or 13. I'm going to have another point up here. And the graph goes like this. I could also have used the fact that the slope is 3, up 3, right 1, to get more points. Anyway, this is the graph of that piecewise function. We're going to do one more together. This time, one of the pieces is not linear, it's quadratic. We've got negative x minus 2 if x is less than or equal to 0. So that means that that endpoint is included. And then we've got x squared minus 2 if x is greater than 0. That piece we would draw with an open circle if it doesn't connect to the other graph. Right. Let's start with the first branch, negative x minus 2. If I substitute 0, I know that's my y-intercept, and that is at negative 2. Let's talk about that slope idea again. The slope of this line is negative 1, which usually means down 1, right 1. but I can go backwards. I can go left 1 and up 1 from there. So left 1, up 1, left 1, up 1, like that. Also, if you think about, if you drew the whole line, right, which would have gone like this, and then you erase the part that's not in the domain, that's another way to graph it. X squared minus 2, I'm going to try a table of values here. So x and x squared minus 2. And I'm going to start at 0. And again, this point's not included unless it lands on the other one. 0 squared minus 2, that's 0 minus 2, or negative 2. That's perfect. That's where the other one is. When x is 1, 1 squared minus 2 is negative 1. So we're going to point at 1, negative 1. 2 would give us 2 squared minus 2. 4 minus 2 is 2. And we'll just go one more. 3 squared minus 2 is 9 minus 2, or 7. So we're going to point at 3, 7. That second branch is the right side of a parabola. All right. There is the graph of this piecewise function. By the way, we didn't talk about, we know what the domain was, obviously, but we didn't talk about range. The range of this function would be square bracket negative 2 comma infinity, because it goes down as low as negative 2, no lower, and then it's got arrows heading up from there. How about number 8? This one's a little tricky. The range for this one, actually the right branch doesn't even matter. If we look at the left branch, the one we graphed first, it goes down almost to negative 8, except it doesn't reach negative 8. And then it goes up from there. And actually, as it goes up from there, right, heading this direction, it also covers all of the other values. So the range from the graph is parentheses negative 8, parentheses because negative 8's not actually an output value, comma, infinity from the arrows pointing upwards. All right, that's it for piecewise functions. We'll come back in a moment and we'll take a look at something called the greatest integer function.